So today we're on box number 3 of radios. There's going to be 2 radios in this box. And Barry's sent in another Cybernet 134 base set with a rather ruffled front escutcheon. There's a good word for Saturday. But nevertheless it should work well when it's done. It's come with the factory original mic. It's got a screw missing out of the mic plug. So I'll tell you what we'll do. We'll put it on and we'll see how it performs before doing anything. I think he's also sent in an Amstrad 900. Now, if it is an Amstrad 900, you can always be assured they're the genuine article and there's no fakes, because it's sending the 901 though, there's the cheaper versions. Right, so I won't open it up. I'll find a piece of paper. You know what, I'm going to use our mic again, and then we'll look into his mic at the end. And then we know where we are. Right. Switch on, and we'll start the power supply at 12.8 volts, 350 milliamps, just in case there's a malfunction on the radio. That's a very stiff on and off switch, we'll deal with that. Just come on channel 20. We're drawing 240 milliamps, so I'll now change the power supply to 1.6 amps at 13.8 volts. Right, normal tone high. We're plugged in. We'll plug in the test instrument speaker. Switch picture in picture on, and I'm actually recording the sound today because you didn't get the Cybernet 3000 I did yesterday because I forgot to switch the microphone preamp on. So we'll key up. What we're guessing, 3 watts like they always are. Well, no. 3.2. Let's hope it's on frequency-ish. I think that's going to go, because we run out of second-hand crystals and all the new ones seem to not work in Cybernets. So that one's doing. Deviation. Wallow. It's actually low. So on the receive, what have we got? Switch the SINAD meter on, put the appropriate camera on. Let's see where we are. Put a bit more volume on. That's about 12. We'll look at the attenuator. So we're 1.4. So it's 0.41 microvolts for 12 dB SINAD. So it already exceeds the manufacturer specification on that. So we'll get the set opened up. Now, other than that ruffled front panel, it's in nice condition. Funnily enough, I've got one with a dodgy front. I wonder if the fronts come unstuck and then get messed with and ruffled up before such time as they get glued back on. Well, that looks genuine. So we'll start with the VCO, channel 40, 4 volts. Is this version a floating chassis? Yes. So I knew where my other glasses were, they're there. So at the moment we're on channel 40, we're going to key up and we should have 4 volts at resistor 4. Well, we're not going to key up. We have got 4 volts, 3.98, so we're not going to adjust that. That's the receive, we're not going to adjust it. Transmit should be 4 volts. That's a little bit high. That's the trimmer. So 3.99 on receive. It's gone up a fraction, so we'll just adjust it again. Tell you what, we'll turn that trim around and start again. Right. Receive for 3.98. Transmit 4.2 something and rapidly dropping. So go to channel 1. And then transmit 1.8 to 2.5, and then receive 1.8 to 1.9 to 2.5. So we're all right. That's fine. It didn't really want adjusting, but there you go. So going to transmit. So that was already at peak. It's already at peak. Already at peak. Get the expensive trim tool set out. Or you find I've got the wrong one. No. So peak is 4.6 watts. Sorry, 3.6 watts. 3.8 watts. And about 4.1 watts. So just go through those again. So make sure we're absolutely at maximum. This is important, you're not going to ever balance it. It's not doing as much as I would like, but there you go. So, clockwise for 4.4 volts, well, it won't do 4.4, so we'll just take it to the point at which it starts detuning, which is there, and then we'll take L9, I think it is anti-clockwise, to 4 watts, which is there. So now we want it to be within 0.1 watt on channel 1 and channel 40. So here's channel 1, and we've got 3.9 something. And channel 40, shade just under 4. So yes, that's balanced fine. So whilst we're here, we'll do the meter. I think that's sticking actually, but anyway, it's the preset there. And that's now set to 4. And now we'll look at low power. battery's not doing anything. You know what, we've got another Duff preset. It seems to be par for the course. Yesterday's Cybernet 134 had a Duff preset, so I'll change that. Right, so I've done that. We get them from Rapid Electronics at 500 ohms. It's difficult to get this skeleton preset, which is what they're called, horizontal skeleton preset. Right, we'll key up now and see whether we... Yeah, now we can set it. Oh, look at that, I just twiddled it, it's 400 milliwatts. Fantastic. And back to full power. Whoops. And we've got, well actually it's about 4.2. But we'll worry about that later. Now let's see whether we can get the thing on frequency. So it's not where I want it to be. It's supposed to be 79125, 79045. We're going to have to let it go at that. We've got no source of new crystals that's reliable other than paying 30 quid. So I used the last one off a scrap chassis yesterday, and this is within legal specs, so 27 79047. Right, where else are we? Deviation. So I want that to be in that position in the center, and then we'll get the little oscillator out. And we'll just bring that deviation up, especially if I put the meter back on. I want it to be 2.2. Wow, that's spot on. So the never exceed is 2.5, and I was just able to get it to do 2.5. So that now will go over to receive. We'll start by putting the oscilloscope on. Turning the bench light off, putting an S9 equivalent signal on, and the detector needs adjusting for maximum recovered audio. And that's again the wrong tool. And that was already spot on. We'll turn that off, bench light back on, volume down a bit, SINAD meter on. We want about 4 dB. Right, so we've got 4 dB on the SINAD meter, thus not making the FM receiver saturated, otherwise we won't be able to effect any improvement. So front end first. Oh, you know what? I've got a bit there. Now we'll go to a bigger signal. Check that one again. It doesn't have as many receiver stages as the bigger Cybernet models. So just recheck that first one. We're getting a little bit, I think. So for 12 dB SINAD now, it's, yes, we have. It's now 2528. We call it 29. Just check the other scale. Between scales as ever. And on this scale it says it's 2.5. We'll give it 0.29. So improve that dramatically. That works well. So the S meter, so put S9 on the signal generator. You know, that's exactly spot on 9. That doesn't want adjusting, but the adjustment is there. And 9 it is. That's excellent. And the squelch, turn the squelch to full. And what I want to happen is when I get to 100 microvolts, I want the squelch to open. So I put the squelch to full on the radio. We're at 3 microvolts, 10 microvolts, 30 microvolts, 100 it's coming. It's exactly where it should be. And that is the preset there. I'm not going to touch it. I don't think this been, the fact the deviation was low, I don't think it's ever been looked at. It's just dropped off frequency with age. So now we're going to check the sensitivity of the squelch. So we've got the squelch to the other end. Set threshold, switch the signal generator back on, and see when it comes in. It's coming in exactly 1 microvolt and leaving it 0.95. So there we go. That's that. I'm just going to put some, I'll either put some oil or some WD-40 on that, the fact that this knob is stiff. So we'll come back to that in a bit. So what happens with these, especially if they've been stuck in a garage or somebody's loft for an eternity, just either oil or WD-40, it's just the shaft, that's it. They can go stiff. What I will now do, I'm going to turn the power off so we're not switching the set on and off, and I'll just work that in. And hopefully that will soon loosen up and become normal. Hasn't done yet, but I'm sure it will. So I'll put this back together, and that's worked out nicely, and we will put it on the aerial and see if there's any good buddies out there at tea time on a Saturday. At tea time, if you're outside of I know maybe in Lincolnshire, but I'm from Yorkshire, so it's breakfast, dinner and tea. Tea's the 5 to 6 o'clock meal. So finally, before we finish this video, I just want to see if I can do something with this gentleman's microphone. It's got a screw missing. I'm going to test the mic first. We've got the teeny weeny screws. Knights at Curtin in Lindsay sell the Curtin in Lindsay. They don't. That's where they are. They have the teeny weeny screws, which are called teeny weeny screws, and I think they're 25 pence each. They were last time somebody got some for me from there. Right, I'm just going to put this microphone on. This is the customer's mic, and I just want to see whether it's actually working. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. It does. Good. So in that case, I'll get one of our teeny weeny screws out in a moment. We'll just run through this set on the aerial and on its own speaker. Just check that's working. It is. So although it looks tatty with that front, it's a very nicely working set. And really the only thing about it was miles off frequency because of the Duff reference crystal. I've seen quite a lot of that nowadays on Cybernet sets. But they are 40 years old now. Right, we've got it on the aerial. One niner Roger. $19 a Roger. Excellent. Well, Mr. Chippy's raring to go, so we're going to do an on-the-air test immediately. So thanks for watching York 861 Cybernet 134 chassis from 1981.